Hello, my name is Mohammed Alharthi, and our study is modeling and testing extendable shading devices to mitigate thermal discomfort in a hot, arid climate, a case study of the Hajj in Mecca, Saudi Arabia. The holy city of Mecca in Saudi Arabia hosts an annual religious event, which is the pilgrimage of Hajj. In 2019, about 2.5 million pilgrims visited Mecca, and the number will increase in the incoming years, according to the Saudi vision for the year 2030. People assemble in Mecca over 1 week period, traveling up to 50 kilometers and spending around 30 hours outside in the hot climate of Mecca, where temperature may exceed 43 degrees Celsius. Temperature in the middle of a crowd increases even more. And because most of the pilgrims are physiologically adapted to their cooler climates and most likely to find Mecca's hot climate discomforting, improving the thermal comfort conditions is very important. It was shown in the literature that shading is one of the most effective strategies of mitigating heat stress. One iconic case study is the work of Otto and Rash in the Prophet's Mosque of Medina in Saudi Arabia. And although within a semi-urban context, it showed that the canopies were capable of reducing air temperature by around 10 degrees Celsius at the time of testing. Here in this research, a shading device was digitally developed to mitigate the thermal discomfort of pedestrians in Mecca on a microclimate level. The shades are square-shaped canopies spanning 30 meters above the ground. The dimensions were best fitted to the pedestrian paths between the two holy sites of Mina and Arafat, which are about 14 kilometers long. Here is an illustration showing the distances between the four holy sites of Mecca, which are visited by the pilgrims. Then a series of different simulations were calculated to testify the shading canopy's effects on the outside microclimate and the thermal comfort levels. These were using Arafat weather file, which was obtained from the Ladybug Tools website for the EPW maps. The simulations included the Universal Thermal Climate Index, operative temperatures, solar radiation levels, and sunshine hours. The scenarios were for the whole year. The days of Hajj 2019, which were from the 19th, from the 9th of August to 14th of August, and for the 10th of August, the most populated day of Hajj. For the UTCI, the Universal Thermal Climate Index, which is scaled between the extreme heat stress to extreme cold stress, the index measures how people feel air temperatures or what it feels like. The UTCI average values that were created under the canopies for the 10th of August dropped from 36.5 degrees Celsius, which is strong heat stress on the UTCI scale, to 31.5 degrees Celsius, which is a moderate heat stress. The annual outdoor comfort levels difference was also clear when applied to the whole year between the shaded and non-shaded areas. For most of the year, In the outdoor, people felt extremely hot for about 41% of the time, especially between the hours of 9 a.m. and 6 p.m., and only about 26% of the time felt comfortable. When the shading devices were applied, they contributed to mitigate the thermal discomfort significantly. For the examined scenarios of the hourly operative temperatures for the extended and retracted canopies, also for the 10th of August, the scenarios showed big difference between the shaded and the sunlit areas, as much as 16%. The most effective happened at 9 a.m. and 5 p.m. Here are more detailed illustrations demonstrating the differences of the operative temperatures. The solar radiation also resulted in a noticeable difference between the shaded and non-shaded areas for the days between the 9th to the 13th of August. The difference was around 22 kilowatt hours per square meter. This difference is a reduction of around 9% between the shaded and non-shaded areas. The last simulation was conducted to show the direct sunshine hours difference for the 10th of August from the 9 a.m. to 3 p.m. between the areas of direct and indirect sunlight beneath the canopies. When the canopies were fully extended, the direct sunshine or the sunlight hours were 1 to 2 hours only, whereas for the fully retracted canopies, the tested area received more than 10 hours of direct sunlight. In conclusion, there was a significant improvement in the thermal comforts when the shades were applied, not only for the days of Hajj, but for the most of the year. A further work would investigate and testify integrating different strategies to mitigate thermal discomfort. Thank you.